In this video, we're going to look at how we can recognize a quadratic sequence. So I've got 3 quadratic sequences here. You can see that they've all got n squared as their highest power. Remember, n represents the position in the sequence. So for the first term, n is 1, second term, n is 2. So here we've got n squared, 2n squared, and n squared plus n. Even though we've got an n here, we've got n squared. So squared is the highest power. That means it's quadratic. Okay, quadratic, remember, always relates to having squared as the highest power. Let's write out these sequences and also have a look at how we can recognize, just by seeing the numbers in the sequence, that this is quadratic. So n squared, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. But let's add in one more term. Let's go for the 25 as well. Okay. For 2n squared, we're squaring n and doubling it. We are not squaring 2n because 2n is not in brackets. So 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. And 5 squared times 2 is 15. Okay, so that's our second sequence. And our third sequence is n squared plus n. So for the first term, 1 squared plus 1 is 2. For the second term, 2 squared plus 2 is 4 plus 2, which is 6. Third term, 3 squared plus 3. So 9 plus 3 is 12. Fourth term, 4 squared plus 4, that's 16 plus 4, which is 20. And lastly, we've got 5 squared plus 5. 25 plus 5 is 30. Okay, now let's have a look at the differences in these sequences. So for the first sequence, like just our n squared quadratic sequence, the differences are 3, and then 5, and then we've got a difference of 7, and a difference of 9. Now what you'll notice is 3, 5, 7, 9 forms a sequence itself, and we've got a common difference of 2 each time. So whilst the first differences are different, if we find the difference of the difference, it is the same. It's 2, 2, 2 every time. That is called the second difference. The difference of the difference. Second difference. Okay, let's see if the same thing happens here. So the difference is 5, 10. Is that right? Oh, sorry, that's a difference of 6, first of all. 6, and then 10, and then we've got a difference of 14, and a difference of 18. When we look at our second difference, and our second difference is 4 each time. So the second difference is not the same as in the first sequence, but it is completely identical every time. So if our second difference is identical every time, we've got a quadratic sequence. Let's just check that one more time. Difference of 4, 6, 8, and 10, which again gives us a second difference of 2. The second difference is identical each time, and therefore we have a quadratic sequence. So we can recognize the quadratic sequence because the highest power is n squared in the nth term, and we can recognize the quadratic sequence because the second difference is identical between each term.